Hi, welcome back to Alvin 14 Presents. My name is Mark. Today I'm going to show you how I built a min box radio. And a min box radio is nothing more than a small radio that fits in a min box, like this one. There's something special about this radio because it only receives one specific station. And that's intentionally done because I want to use it as a radio for emergencies. In case there is an emergency broadcast, I can just switch on the radio and listen to this one station that is pre-programmed in the software. So when it's all hectic, you don't need to search what station and wondering if it is the right station, because it's already predefined by you, and then you switch it on and you listen to whatever you need to hear. So let's get started. Okay, let's start with the schematic. On the bottom left we have our Arduino Nano. Control speaks for itself. On the right we have our radio section, and basically the radio, it's a TEA 5767 chip with some small components on a little piggyback that we will put on our PCB, and it has an audio amplifier. One thing is special though, and that's capacitor C1. I'm using C1 to connect our antenna signal to the headset ground. That way, by binding the two, we can use our ground from the headset as an antenna for our FM receiver. It's optional, you can leave out C1 or leave it in, whatever. Another option is to connect a wire to your tin can and use that as an antenna. But when you do that, make sure the housing is not touching any other parts of the PCB, like ground, for example. And this will do the trick. It has a very nice reception using this as an antenna. Then we have a power section. Basically it's fed by 3 coin cells, and the power supply looks complicated. It's optional, you can leave it out and feed everything through the USB connector. If you just want to experiment, that's fine, but if you want to build a portable radio, this is useful. But basically it's a microcontroller control power supply. So basically I can use the push button to activate the power supply. The microcontroller will take over by opening a FET that takes over the push button to leave the power supply activated. And then at some point the microcontroller can say no more and shut down the power supply, and it goes back to battery safe mode. So there's all there is to the schematic, so let's start assembling the PCB with our SMD components. Okay, so we need a few components. We have, of course, a min box, which could be any metal case, and the metal is quite important. Doesn't have to be, but later you will see this will function as an antenna as well. So that's why the metal is useful. We have a little PCB that I designed. You might do without, but you have to take a look at the schematic to change and leave out the components you don't want. We have 2 antennas that we can use. Of course, we have an Arduino Nano. We have a small radio module, some battery clips, a connector for the headset, a push button that I want to use to switch on the radio and turn it off again. And of course, we have a little small SMD components that I nicely sorted on numbers that are compatible with my part list, so I can just pick and place later while soldering. So let's get started on soldering. So let me move this project carefully under a microscope, because that's where I'm going to solder this. So the first thing I'm going to do is apply tin on one pad of each component regarding the SMD components, and then I will just tweak them in, because I'm not going to use solder paste. Okay, so all my components are already on the placemat, and each component has a unique number corresponding to my part list. So it's easy for me to just place the components. But before I do that, first I will solder a single pad for each component, so it's easy to place the components. then we go to the through-hole components. We have our connector for the audio. We have our micro switch or push button. And we have some battery clips. Like so. And the battery clips, and one of those clips is tricky because on the other side there's the PCB board, and I don't want it to push against the back of that little piggy bank. Well, let's do the other ones first. The other side I solder from the top. And there we have it. One thing remaining, and that's our Arduino. Make sure you orientate it the right way, like so. And then we start soldering. Now I recommend you don't solder all the pins for now, only the ones that are used, so in case you need to take it out, you can always take it out, because let's not forget, we're not using any sockets to save space. So that's why. And this is your PCB. Of course I still need to clean it a bit because all the soldering residue is clouding up my clear view of the PCB, because I want to check if there's no short circuits that I made. So I'll carefully inspect this, and then I'll hook it up to a power supply, program it, and see what happens. Okay, so I've got my radio, my antenna, and I got a min box. Choose any as long as it fits. It's designed for a small box like this one. You get them in many brands, so the brand really doesn't matter. It's just what I usually consume and have around. So today I'm going for the black one. Okay, so to make it easier, I made a little template like so, and then I'll just stick that onto it there. So that's what we're going to do, and then I'll just attach it with a little piece of tape. And now all I need to do is drill the holes as mentioned in the drawing. Yes. Okay, now holes are ready, and to place the electronics I'm going to remove this little pin. There we have it. So it's easy to put it back later. I'm going to save this one, put it aside. Perfect. That's how it's going to fit. Okay, everything's ready. So I drill a little hole in the bottom where the antenna screw will go, and the antenna will just be screwed in here. I just tighten that. So this should fit the antenna. Nice. Like a little spy bar. PCB will just go in here. And now you know why I didn't include any batteries at this point. Not yet anyway. Perfect. There we have it. A min box with a radio. But before I there's still a few things that needs to be done. We need to wire up the antenna, and since we're using the whole house as an antenna, all I need to do is solder a wire to the house to the PCB. not basically pick any spot in the housing that you think is good enough, like so. So let me wire the antenna like so. Okay, now you would say we're good to go. However, pay attention to this. It's a metal box, it's electronics, risk of short circuit for sure. So I am going to apply some tape to the PCB so it will not be in contact with the housing. Okay, now first let me hook it up to my power supply, because if there's a short circuit then the batteries will be drained empty quickly, and I don't like that because I only have a few around. So I'm going to use my power supply to test everything. Okay, for my test I'm using a multi-com power supply, and it's way overkill because it's a very powerful supply. But the good thing is I can limit the output, and I limit it to 100 milliamps and 4.3 volts. So whatever happens, if there's a short circuit, the power going to the PCB is limited, and hopefully any damage that will occur as well. So let me just switch it on, and as you can see it drains 30 milliamps, which is not a lot. So that's perfectly fine for our radio. Now I'm confident enough to hook it up to the batteries and install it in the housing and do some programming, and of course we'll do some testing. Okay, so first things first, we have a few libraries we're using. We're using the wire, which is a default library, the radio and the easy button. You have to install those. Make sure you're using the right version. We include our libraries. We define our button. In this case, it's a button on pin 35. We define our radio, and this is important. This is where we set our station. If you want to change to a different station than mine, you need to change this number. And then recompile and upload, of course. In the setup, we do an initialization of our radio. Then we do something specific with the power, which means if I press and hold the button, at some point the microcontroller will initialize and activate the output on A3, which is pin 5, and that will overrule the button initializing the power supply for it to stay on. And if I press the same button again and hold it for about 5 seconds, it will go off again. It will lower that pin and the power will shut down. We also have our main loop, of course. In the main loop we constantly read our button to see if it's pressed, and other than that we give some feedback on our radio station. Every 3 seconds it will be printed to the serial port. And that's all there is to it. It's easy peasy. So all you need to do is program and upload, and you're good to go. Okay, so in the software I pre-programmed one station, and for my case that's the local station, and in case of an emergency that's where they will broadcast, and in the meantime it's just another radio station. So to switch on the radio you press and hold the button for 2 seconds, and to turn it off again you press and hold it for 5.
Er zouden tientallen doden zijn gevallen. Veiligheidsregio's maken zich zorgen over de hulp van het leger bij natuurrampen. Wel, dan blijft dat wel zo. Nu Defensie het steeds drukker krijgt met veiligheidstaken. Contact met Olaf Stroopman van de veiligheidsregio Noord- en Oost-Gelderland. Daar wordt de inzet van de...
And that's all there is to it. This is all I have for you today. I hope you enjoyed it. Remember to visit the Element 14 community. There's a project page where you find all the information you need to rebuild this project yourself. You can leave comments and ask me questions, and I'll do my best to answer each and every one of you. In the meantime, I'm going to start working on my next project, and until then, I see you next time.